All right, let's talk about something we all wrestle with, but maybe don't think about too much. Numbers. Specifically, those crazy big or super, super tiny numbers that just feel clunky. Today, we're going to dive into a new way of looking at them, a way to get a real handle on both scale and precision.
I mean, really, why? You know that feeling, right? You're reading an article, maybe about astronomy or the economy, and you hit a number with a long, long trail of zeros, and your brain just kind of shuts down. It's a real thing, and it begs the question.
Look at this thing. Just look at it. You have to stop what you're doing and literally count the zeros to figure out what you're even looking at. It's inefficient, it's easy to make mistakes, and honestly, it keeps us from really feeling the size of the number.
And that brings us to our first section. It really is a numbingly big problem. The sheer range of numbers we have to deal with in the modern world is staggering, and our brains just weren't built to intuitively grasp it all. So you have to think, there's got to be a better way to do this. And of course, there is. We're about to look at a system that's so simple and so elegant, it turns this numerical chaos into something that makes perfect sense.
The whole secret is to just shift our perspective. We're going to stop obsessing over the exact number and start thinking in terms of its magnitude. That's the key concept from our source material. And trust me, this one little change makes all the difference.
So, let's take a number we all know pretty well. 1 million. A 1 with 6 zeros trailing behind it. That's the old way. Kind of annoying to write. Now let's see the new way. Here it is, the big reveal. We just count the digits. Or, for the more technically minded, we're taking the base 10 logarithm. So 1 million with its 6 zeros becomes just 6. 1,000, that becomes 3. A billion, 9. All of a sudden, these massive numbers are just simple single digits. We just pop them in parentheses so everyone knows we're talking about the magnitude. How simple is that?
Okay, now that you've got the basic idea, let's lay out the rules of this new language of scale. You'll see it's incredibly consistent and easy to pick up.
And here's the really beautiful part. It works perfectly for both huge numbers and tiny ones. For big numbers, the magnitude is positive. You see, a trillion is 12. For tiny numbers, it just goes negative. A thousandth is -3. A trillionth is -12. And what's right in the middle? The number 1. Its magnitude is 0. This is our anchor point, our foundation. We call it the unit.
So what about 0 itself? Well, in this system, 0, with all caps, isn't really a number you can measure. It's more of an idea. It basically means this quantity is so small, it's beyond the limits of what I can currently detect. It's a way of being honest about the limits of our own tools and senses.
So we've got the scale, the bigness or smallness totally covered. But that's only half the story of any real-world measurement, isn't it? The other half is all about precision. And this is a fundamental truth of the universe. It doesn't matter if you're using a tape measure or a super advanced laser interferometer, every measurement has some amount of uncertainty baked into it. The important part is knowing how to communicate that level of certainty. And you guessed it, this system has a fantastic way to show precision too. See, if I just write the magnitude as 3, notice that decimal point, I'm telling you it's an estimate. It's roughly in the ballpark of 1,000. But if I write 3.134, whoa, now I'm giving you a highly precise measurement. The number of digits you see tells you exactly how much confidence you can have in that number. Which brings us to this fantastic quote from the source material. Being truly literate with numbers, or as the author calls it, measurate, isn't just about knowing if something is big or small. It's about also knowing how well you know it. That's the real difference between just spitballing an idea and making a real scientific claim. Now, all this talk about precision might sound a little intense, like we have to be super exact all the time. But actually, that's not the case at all. In fact, one of the most useful skills you can have is knowing when an estimate is perfectly fine. You know, for most of our day-to-day thinking, for those quick back-of-the-napkin kinds of calculations, we don't need a bunch of decimal places. Just getting the scale right, what scientists call an order of magnitude estimation, is an absolute superpower. Knowing that something is around 1,000 or 3 is often all you need to make a good decision. So really, it's about using the right tool for the right job. For most of us, most of the time, we're everyday users. Our goal is to get a good enough picture to navigate the world. We can leave the really hardcore work of chasing down every last significant digit to the metrologists. Those are the specialists who live and breathe the science of measurement. For the rest of us, being a good estimator is a crucial life skill.
So there you have it, a really powerful way to think about scale and precision to truly master the number part of a measurement. But a number all by itself is pretty meaningless. A magnitude of 3 isn't just 3. It's 3 kilograms, or 3 kilometers, or 3 seconds. And that opens up a whole new can of worms. What exactly is the other side of this coin, the unit? Well, that's what we'll explore next time.